click on Naïve Classifier. So what is the next step? As you reach that point, you are going to select your variable, of course. And now, can everybody tell me what is our dependent variable? Exactly. Our county is the independent variable. What kind of variable is it? It's a categorical. So we choose county as a categorical dependent, and we choose assets and income as our continuous predictors. Right? Okay. So far, everybody's following. Now, we have to set the parameters right. Okay? We go to sampling, which is the second drop-down window. Okay? And normally, remember, the training size, we always have to set it up higher than the testing size in our sample, right? So, usually, intuitively, 70% is always considered. But like I said last week, it can go all the way up to 80, depends on you. But the training data set normally should be higher than the testing data set. Okay? And we set it to 70%. And we click the box, we tick the box of divide data into train and test samples. Okay? Next thing to set is the distributions. We don't have to worry about memory usage. Okay? Now we can click on OK. No, don't do that. The default is good enough. Okay? We click on OK. And then another window pops up where they describe whatever steps we just did. Okay? We set our dependent variable, the independent variable. They tell us our sample size, okay, for the training and as well as for the testing and overall. Normally, how many data that we have? We have 32 cases, right? Okay, so 70% of our 132 cases would be 92 cases for the training set sample and 40 for the testing sample. All right. Now, you see it here? Don't you see it on your screen?
On my screen I have 23 because I left it 75 for.
Well, okay, good. Normally, 70% is usually the most common that you will find, but 75 could be okay too. As we believe 70 is the lowest threshold. So, okay. Now, with that being said, we are able to see the descriptive statistics for both for the dependents and as well as the independents. Okay? Now, one thing to see clearly, we are working with the testing data set. Okay? Now, we also select the training, okay? Let's go back on that so you can see. First, we set up our 70% and then this pops up, we see it's the testing data set. But we want to see the training data set because remember, the 70% is for our
training.
Nobody's following. So,
they were randomly to
yes.
select.
So basically the tick box from testing to training. And now we check the summary. Okay. And then we can see the descriptives. Yes. You go back again. And the model. Okay. So step by step we can see everything that we need from the summary, okay, to the model, to the descriptive statistics about everything. Now, what we want to see the predictions, okay? Because remember, this algorithm helps you to classify. Based on this name, you already know it's a classifier. So it helps you to classify your cases whether they were predicted well or not well. So you go back again to your analysis. So we can see the prior probabilities. Which was, prior value was 0.2. Okay, and for Highland we had 0.33, and for Rogers we had 0.39. Okay, for Dutch we had 0.27. Okay, now still all of those information are necessary for you to get a knowledge of the results that you are getting before you actually go straight into the predictions. Now, to yield the prediction results, you can click on, we go back to quick, and we click on predictions. Do you see the predictions? Okay. Now, we can also include the accuracy level, and I believe this is a box predictor.
Yes.
So, yeah, and click on the predictions again. Okay, you go back to your to the window that has popped up. Okay, to the quick, and you tick the accuracy box. From that point on, you're able to yield your prediction and the accuracy level simultaneously, and you can compare where your predictions were accurate or not. Are we all able to see that? So, remember, what is important to know about Naïve-based classifiers, they make strong independence assumptions between all the features, okay? They make strong independence assumptions between the features. What that means is they make the assumption that no matter a feature is present or not, it doesn't influence the other features. And I was explaining at the beginning, that's why this is called naive. Because this is a very naive way of thinking that features are unrelated to one another. This is a very naive way of thinking. So, now that we have performed our Naïve-based algorithm, we are also able to see the predictions for the testing data set as well. Remember, the first one we just did was for the training data set. Now we go back to we select the test. We select the test symbol. We still keep the accuracy box and yes, we yield the predictions. So we can see which cases were correctly or incorrectly classified, both within the training and testing data set. We are also able to see the histogram to have a better sense in statistical terms of what was accurately predicted or not, okay, we can click on the histogram to yield the histogram both for the testing and for the training. Of course, each time you're gonna have to tick the box of whether it's training or testing, okay? Has everybody been able to do that? So we can see how many cases were correctly or incorrectly classified. And okay. And we can also see by counting, okay? We can see within the counties to see which one was accurately classified or not. Still, we can yield that histogram as well, okay? We still go to the quick, okay? And we go to the overall. Not the testing, not the training, but we want to see it overall. And we're going to click on the descriptive statistics. It will yield the confusion matrix for the whole sample. Has everybody seen that?
And go to descriptive.
I just said, we go back to the quick, we tick the box for overall, okay? Because the confusion matrix, we want to see for the whole sample. You can do it by training or testing, but it's still better to report it as overall. Now, as we did that, we click on descriptives. And it should yield the confusion matrix for us. Did everybody get that? Yeah. The confusion matrix gives you a better sense of your sample and where or which group or which class, because we are classifying, so we are dividing by class, and where your errors happen, okay? Now, we can see that Rogers and Highlands were the ones that were having most of the incorrect classification.
Yes.
Okay? Do we understand that part? The confusion matrix is really important for you. As you are classifying, you need a sense of where your mistakes happen, where your incorrect classifications happen. And that's through the confusion matrix that you are able to get a sense of that result. Okay? These are the main results that you might want to yield from your Naïve classifier. Moreover, let's go to moreover. Okay? We want to see the default prior probability, okay, calculated from our data for the overall sample. Still for the overall sample. Okay? For example, if we consider okay, now if we consider our dependent variable county, right? And we want to see for the overall sample what were the predictions, what were the descriptive statistics. We can do that from this window here. Okay? So let's click on descriptives. Oh, we already have the descriptions. Let's click on predictions. Yeah. Now for the overall sample, we have a sense of where every mistake happens. Not just for the training, not just for the testing, but for all the sample. Okay? Predictions. and that's needed for our Naïve-based classifier. These are the main results that you need when you're performing a Naïve-based classifying algorithm example.